Yes.
This is 7x squared.
Oh, 7.
Can we use our notes?
You can use your notes, yeah. So 2x cubed minus 7x squared minus 4 divided by x minus 3. All right, let me get started with the first step and then see how far we take, okay? Just like the typical division, right? You write out this first one. Now, notice that, what do you notice about this? This is kind of like, it has 3 terms. But what's odd about this?
There's no zero x.
There's no x term, right? It has an x cubed term, x squared term, but no x term. And you're talking about, descending factor. So you can add a 0x right here and then minus 4. Because each slot is devoted into a term in a polynomial of a particular order, right, of power. If you have a third power, you descend from third power to square to 1 power to 0 power. But if you lose that space, you won't be able to divide it correctly. So you want to keep that 0 term, 0x right there. This is the odd part of this particular problem. And then you put the x minus 3 in front right here, and then you say, okay, this is the lead term x. You have an x, but your lead term right over here is a 2x squared, 2x cubed. So you know that if you put 2x squared here, that means 2x squared times x gives you 2x cubed. 2x squared times negative 3 gives you negative 6x squared. Right? So once you do that, then you can put a minus in half parenthesis and then draw a straight line across. And then you subtract, right? 2x cubed minus 2x cubed is gone. No more of the x cubed term. Negative 7x squared minus negative 6x squared is negative x squared. So that becomes a new lead term. Bring the 0x down, so plus 0x. So now you're comparing lead term to lead term again. You look at the x and you look at the negative x squared. You say, okay, what can I multiply by x to get me negative x squared? Answer is? Yes? Negative x. Negative x. So negative x times x gives you negative x squared. Negative x times negative 3 gives you positive 3x. Put a minus sign, half parenthesis, line across. This minus this is gone. 0x minus 3x gives you negative 3x. Bring the negative 4 down here. Now you're dealing with the lead term and lead term again. And you say, okay, if you do this, this is x, this is negative 3x. I will multiply by negative 3. So negative 3 times negative x gives you negative 3x. Negative 3 times negative 3 is positive 9. Subtract, half parenthesis, a line across. Negative 4 minus 9 gives you negative 13. So you end up with a remainder, right? This is a remainder. Remainder negative 13.
Yes.
You good?
Yeah.
Coding works.
Yeah.
Coding works.
Oh, yeah.
Oh, I forgot about that. I forgot that.
Very fast, so you don't miss.
I will.
Question.
You should decide 0x if there's no regular x.
Yep.
For anything.
Yeah. If you have a gap, Now, this is really important. One question asked is, do you put 0? I mean, if somehow there's other terms missing, do you also put 0 or something? I say, for example, if you don't have the x squared term, you go from 2x cubed minus 7x minus 4 and no squared term, then yeah, in the typically what would it be in the squared term for the 0x squared? Does that make sense?
Yes.
Whichever was missing, you want this to be in a descending power pattern, right? X to the cube, x squared, x1, no x, right? You have to have proper spacing so that you don't get confused. Imagine if you didn't have this and this gets scrunched up, then this top portion wouldn't work, right? You can see that, right?
We write the remainder as negative 13 divided by x.
Yeah. In a moment. So ultimately at the end, right? So the answer, right? When you divide these two, your answer, like this is in many ways is written like this: 2x cubed minus 7x squared minus 4 divided by x minus 3. Right? Dividing is fraction. Now, I show you here in this particular form as a way to anticipate the next chapter, which is happening when we come back after the Christmas break. We're going to be talking about everything in this kind of fraction form, like this. And so it's good that we now are getting used to it. Whenever we're thinking about division, we're thinking about fraction. Polynomial can be in fraction form. So if that's the case, that means the answer is 2x squared minus x minus 3. But that's not the only answer because we have a leftover or remainder. But the remainder is simply be the negative 13 over the same fraction, right? Because it's divided by that whole fraction, right? So it's the negative 13 over x minus 3. So this then becomes your final answer for this division. This is called a long division process, right? This is called a long division.
I don't like that word.
Long division. Now, over here, I'm going to use, I left a space here on purpose. I left a space here on purpose. What I'm going to show you is this thing called synthetic division. This is called a long division. This is called a synthetic division. So let me show you what we do with that. So this is a new concept. We're going to do another problem doing 2 ways. Okay. So we have this divided by this. So this is what we do. We take the 2x cubed minus 7x squared plus 0x minus 4. Again, I don't forget that 0, right? And this is what I do. I pull out the number. I put on 2, negative 7, 0, negative 4. Now, since this is dividing x minus 3. There is no number in front of x. This is the first thing I checked. No number in front of x, which is great. And then there's a minus 3. There's a minus 3. Now, what I usually is looking at is a x minus b, and just looking at b. This is an expression of x minus something that is positive. So this b in this case is 3. So I put 3 over here, and I put a little, right angle over here. And then I will leave a gap right here, and I draw a line across. I'll pull down the 2. And I say, okay, 3 times 2 is 6. So I put 6 right here. -7 plus 6 gives you
-1.
-1. So then I do the same thing. 3 times -1 is -3, and -3 goes here. Zero plus -3 is -3. 3 times -3 gives you -9. -4 plus -9 gives you -13.
And then you just add the x.
This is your remainder. These 3 numbers are your coefficient of your answer, the factor. This becomes 2x drop of power instead of 3 is squared minus x drop of power becomes 1 and then minus 3.
Are we allowed to use this on the test?
Yeah.
Cool.
You have to know how to use it though. So synthetic division without doing all these x's and all that stuff, basically doing exactly the same thing, but just pulling the number out a little bit faster and then kind of doing this across, right? Going this across, right? Like that. And they end up right there. So again, you can say, okay, so this divided by this, divided by x minus 3. The answer is this plus the remainder, -13, over the original factor, x minus 3. There you go. So there's your answer using synthetic division. I'm gonna move over here and give you a different problem, and I'm asking you to solve it 2 ways as well. So new example. X cubed plus 5x squared plus 6x plus 9 divided by x plus 3. 2 different ways. Long division. Synthetic division. Go ahead. All right, so this thing here, I'm going to just rewrite the whole thing again. X cubed plus 5x squared, 6x plus 9. All right, now these are in descending orders. There are 4 terms, power 3, no problem. I don't need to use any placeholder. Divided by x plus 3. So I'm looking at the first lead term, right? So I say x times 1 will give you x cubed. Well, it's obviously x squared. So x squared times x cubed. X squared times 3 is 3x squared.
Oh.
All right, subtract, line over. 5x squared minus 3x squared gives you positive 2x squared. All right, focus on here now. And then you look at the lead term x and 2x squared. Then you say, okay, this must be plus 2x. Because 2x times x gives you 2x squared. Now I need to bring down the 6x, right? Positive 6x. So 2x times 3 is actually 6x. So subtract, this gives you 0. Well, so that means you only have this left, right? So there is really nothing else left except that 9. So it works out pretty nicely. So you know that the answer is x squared plus 2x plus 9 over x plus 3, right? Because that is our remainder, right? Because the division measure. Okay, so that's using the traditional long division process. Then if we want to do the synthetic division, x cubed plus 5x squared plus 6x plus 9, I will use 1, 5, 6, and 9. Right? Now, this thing right here, what number do I put here? Yeah.
3.
3?
On -3.
And -3. Remember, it is x minus b. Right? X minus b. That's the form, right? And if we have x plus 3, then b is -3. Right? So we use -3. So bring this down. This is 1. -3 times 1 is -3 right here. 5 and -3 gives you positive 2. -3 times 5.
If it's supposed to be positive 2, why do you write 5 at the bottom?
You got a point.
What happened?
You wrote 5 at the bottom.
Positive 2 and then row 5.
And then you wrote 5 instead of 2.
Sometimes I burn my arms. So there you go. Thank you. Now, -3 times 2, -6. And obviously this is 0. There's nothing else. Then you bring this down to 9, right? And so this is part of your final answer. This is your remainder. So your answer is 1x squared plus 2x, right? That's it. And then plus 9 over x minus 3. Questions on this? Is that clear? So got you 2 examples, this one and this one, with 2 different ways of solving it, step by step. Okay? All right, on the board says remainder theorem. There's a complex, sort of a complicated discussion that I can have with you on remainder theorems. But I'm trying to strip down to the most simplified or essential part of the remainder theorem. And the remainder theorem really basically says this, and I'll show you an example of what that means, is that x minus a, I can say b, maybe let's do it this way, x minus b, because we used b earlier. We use a b over there. X minus b is a factor of a polynomial if and only if. Now this term if and only if you continue to go on to pre-calculus and calculus, if and only if is a very important mathematical statement. That means it's the only condition that whatever this says in front of it can happen. If and only if P of B is equal to 0. Very simple idea, right? P of x is a polynomial function, and B is whatever the number that is any number under the sun. But there could be a number that if you put it into the x, this whole thing becomes 0. And if that's the case, then x minus that number becomes a one of the complete factors of that whole polynomial. What do I mean by that? Let's just use an example to discuss this, right? If I have today f of x is equal to 2x cubed plus x squared minus 13x plus 6. And this is 2x cubed minus x. Okay, this is then if this problem says, okay, factor, ask you to factor this, you'd be like, well, how do we factor this? It's kind of hard, right? There's no identity that we have memorized in the past that this will fit into those patterns. It's not like it's easy to factor anything out. But what we notice is that there are some telltale signs. Particularly is looking at the lead term and the last constant term. There are some possible b's. And they are all usually the factors of these two numbers. Okay. And just hypothetically say, let's take b as equal to 2. So 2 is possible factor, 3 is a possible factor. Not all of them are going to, at 2, 3, -2, -3, obviously 6 is 1, -6 could possibly be 1, and so on and so forth. Right. So there are multiple possibilities that you have to test it out. Now, just for the sake of argument, let's say that let's try b equal to 2. Let's try b equal to 2. If we try b equal to 2, according to the remainder theorem, b is equal to 2, and when 2 gets put into x, the whole thing should become 0. So if b turns out to be the factor that will give me the x minus b as a complete factor for that polynomial, then f of 2 should equal to 0. But if it doesn't equal to 0, I have to try something else. All right. So if I do that, okay, let's try that. If f of x equal to f of 2, let's see what will happen. 2 times 2 to the third power plus 2 squared minus 13 times 2 plus 6. Go ahead and use your calculator and say, well, what is the answer?
Oh no, it works. It works.
It works?
Yeah.
Is it equal to 0?
Well, 2. You first will get 16, and then that will get 4, and then that will get 26, which will get you, -6, -6 plus 6.
Yeah. So this just simply tells me, very simple, right? This tells me that x minus 2 is a factor for this polynomial. We can test it out. Let's try another one. I'll use a different color. Try. Let's try. B equal to 3. So f of 3. Let's give it a shot. 2 times 3 to the third power plus, right, because you use this x, right? 3 squared minus 13 times 3 plus 6. What do you have?
25.
25?
I have 30.
Alright, I need multiple people to confirm the answer.
How did you get 25?
60.
Let me see what you.
I'm getting my
Come on, you don't say you have calculated. Help us out.
Yeah,
Help us
You
out.
messed up here.
It will get you 30.
I had 35. You got 30. Who else got 30? You got.
Oh, I messed up. My fault.
I think I'm wrong.
I got 2 votes on 30.
Actually retract this one.
I retract my
Democracy.
answer.
Huh?
It's 30.
It's 30. Okay, 3 votes on 30. Anyone else can confirm? You confirm? 30. Okay, we got 30. Okay, so we got 30, which means x minus 3 is not a factor. Now, we can figure this out, right? We can see if it's really true. Let's say if x minus 2 is a factor, then we can divide, right? We can take f of x and divide by x minus 2. Okay, so I'm going to go ahead and do a long synthetic division. 2, 1, negative 13, 6, and then 2 is my factor, right? So bring the 2 down. 2 times 2 is equal to 4. This gives you 5. 2 times 5 is equal to 10. This gives you negative 3. 2 times negative 3 is negative 6. Gives you 0. Hey, right? No remainder. So your factor, your final factor is 2x squared plus 5x minus 3. In fact, I can say this times x minus 2 is f of x. Do you see it? Do you see it? Do you see how this, I can prove that x minus 2 is a factor. In fact, I can continue to factor this out, right? Maybe this is a trinomial. And if I can factor this out, this can become what? 2 and 1, 3 and 1, and then maybe minus over here. So 3 times 2 is 6. 1 times 1 is negative 1, gives you positive 5. Positive 5 gives you the 5x, right? So I have 2x minus 1, x plus 3. Whoa, I just factor out this whole thing. I just factored that out, the whole thing. Okay? Now, I keep building up on this. I can keep building up on this. And I'll show you what happened next. Now, notice. If I give you a problem like this, and you say, wait a minute, I've never seen this before. Well, you actually did. But number one, in order to graph, we need to know some essential points on the graph. And I said find zero. Find zero means is whatever the points number that you put into f of x that will make the whole thing 0. Now, didn't we just find that earlier? We found that 2 is one of the zeros, right? Because when we put 2 into the f of x, boom, gives you 0. And that one gives you one of the 3 factors. So what that means is you could have 2 more zeros. And then it says graph, a factor, what we just did. right? So in many ways, it's possible that we will simply just try to go through this, right? Using remainder theorems. Try b equal to 2, and since I works, so we end up with f of x is equal to 2x squared plus 5x minus 3 times x minus 2. But remember, we can key factor this. We can factor this. And then we end up with f of x is equal to, we say, is equal to 2x, what is it? 2x minus 1, x plus 3, and x minus 2. Now, the first question says finding 0. That simply just means we are setting this up equal to 0. Now, if this is 3 things multiplying to each other equal to 0, that means 2x minus 1 is equal to 0, x plus 3 equal to 0, x minus 2 equal to 0. This one we know, x is equal to 2. That's one of the zeros. What does that mean by zeros? That means y is equal to 0, right? That means your x coordinate is 2, y coordinate is 0. That's what zeros mean, right? This one is x is equal to negative 3, so that means you have negative 3 and 0. This one means 2x is equal to 1, x is equal to 1/2, so you got 1/2 and 0. 1/2 and 0. Now, this problem calls for 3 actions. Finding zeros, graphing it, find factors. I already got factors, so done. This one I'm done, right? Because we got this. Finding zeros, we got this. 1, 2, 3. Last one is to graph it. How to graph this? I know this is a cubic function. So it's going to go like this. So right now we have some points right here. We got 1, 2, so 2, 0 right here. So we got this point right here. We got 1/2, 0, 1/2 0 is right here. This is 1, so 1/2 is right here. And then negative 3, 1, 2, 3, negative 3, so negative 3, 0. We have 3 zeros over there. Now, your graph, because it's a cubic function, and it's going to hit 3 points, it can go like this. Up, down, up. Or it can go down, up, down. Right? You have 2 options. You can have this going up and down and up, crossing the zeros. Or you can go down, up, down. Well, very easy to figure that out. How do I figure that out? I pick a number that's smaller than negative 3, say negative 4. I put it into the equation. I see if I can get positive number or negative number. Does that make sense? If I get a negative number, that means this is coming up like this. If I would use a calculator, this is where the calculator will be helpful. And I'll share the screen. Let me quickly identify this. So I got 2x 2x
I reload on the ferries. Get mine. We'll go get more.
Minus 13 x plus 6. Let's graph this. Now, notice we start for the low and going up high. This typically is because we have a positive value in the lead term. If this one would have been a negative, it's going to go down like this. Does that make sense? We did long division the traditional way. We did a synthetic division. And you see how the number works out until at the end you get a remainder. But we also notice that if your remainder turns out to be 0, whatever that you're dividing can be part of your factor. Does that make sense? And that factor becomes this. Right, so we went from just trying to do long division just for the sake of it as a skill to turning that into a very important idea. And that idea is this one, is to say that if you have a b that is part of your factor, you're going to get a 0 here. Now, by taking advantage of that, then you end up with turning the whole polynomial into, you identify a factor and you know the rest of it. By doing so, you can continue to factor furthermore to become multiple factors. Now, these factors, because they're all multiplying to each other, you can set them equal to 0. Each one can be equated to 0. If each one is equated to 0, you end up with this. 0, 0, 0, and gives you a very specific point that has a real meaning on the graph. And zeros are the ones where the graph will intersect or cross the x-axis. So at the end of the day, when I test you of all these concepts, I'm not going to give you a problem where it says, hey, there's a function and divide something. That's not that easy. That's some, I'm not going to give you that kind of simple problem. What I will give it to you is a problem like this and say, hey, I give you a problem like this. You got to find factors, you got to find zeros, and you're going to graph it. And then you take all the skills that you learn and piecemeal together. That is your entire unit 2. That's it.
Okay.
Got it? You get this, you get unit 3. Have a good day.